Okay. 5, 4, 3, 2, 1.
Okay. Greeting to all. I'm Giriraj Verma from Webtech Technologies. I say my thanks to all the eminent viewers, panelists, and to the respectable participants of the railway organizations, railway boards, zonal head offices, state metro head offices, honorable railway ministers, and MAHUA. Thanks to all for listening to me. I will present you on the technology part on green HVAC systems in railway systems. So today I will be speaking about Webtech position and the strategy on HVAC and refrigeration air conditioning. Then I will be talking about technology part, basically 3 points I wanted to mention it today, which is air quality, focused on safe and healthy air delivery. Then refrigerants, which is focused on green air conditioning. Then fresh air controls, which is focused on energy saving. So let's take the first part. What is a Webtech position and the strategy? Webtech is not a new name. I hope everybody knows about it and its products and services and solutions that we offer worldwide. Specifically on the heating, ventilation, and the air conditioning, we are the #1 worldwide supplier for the railways, specifically in the open market, on many major platforms and programs. The earliest endeavor that we had it in HVAC industry was in 1952. It has been 60 plus of years. We have it started then. Just to see the last milestone, 2018, we have supplied 5,000 plus units across the world. And overall, it's around 1 million that we have supplied till now. What we do is here is tailored product, customized products to various train operating agencies and all the metro rails and long distance train solutions. We are actually working as a global partner for providing the engineering solutions, productions, and support all across the world. We have system design capabilities across our various offices in the world. This can cater to all the comfort amenities, ducts, heaters, exhaust services, heating, ventilation, air conditioning systems, and all. We offer our solutions to all type of train applications, which are very high speed, which are pretty new to India. Locomotives, EMU, DMU, MEMUs, LRVs, metros, and recently Metro Neo, which is started in India. As a responsible, a solution provider for air conditioning, we do a lot of technology excavation in providing green HVACs with ecological and efficient refrigerants, alternative refrigerants, also on the energy consumption and optimizations. We basically, at this point of time, harvest on 3 main pillars: sustainability, air quality, and the energy saving. Sustainability basically is nothing but providing the solution which are long-term sustainable, because we all know that in the current scenarios, because of the impact on the environment, there are a lot of rules and regulations which are coming in. So we are providing solutions, making the product which are long sustainable. Recently, we have seen it that COVID pandemic has taught us a lot on hygiene and making the air more healthier, and quality of the air has to be much better. So we have developed certain products for that. One of the product I would be showing it in my presentation in coming slides, and same on the energy saving. Let's talk about the green HVAC first, and which will give the uh, a good air quality. We call it a blue filter, and what it is. Basically, just to talk about the emphasis on the effect of let's say not so good or polluting environment, we have seen it that it creates a lot of health hazard. Specifically, when we talk about let's say SARS, H1N1, and recently COVID-19, we have seen the effect of it, and we have actually also seen that how important it is to have an healthy environment inside it, and which is not propagating and risking life from one passenger to another passenger. So we have basically a solution for that. It's basically an opportunity to provide a good solution from the car operator to the passengers. So here you see the blue filter, which is actually a directly replaceable from the existing filter, which is actually eliminate up to 92% of the viruses and 83% of the bacteria. All what I'm saying is tested and certified by TUV Nord as well as TUV South. It's basically having two variants in it. One is a standard, another is a premium. Premium will be having a extra carbon layer, which will be having more, let's say, a better air quality delivered into the cabin. Slightly costly, but there are two versions of it. We have seen it and tested it and also get it certified, as I said it before, by TUV Nord as well as South, that it captures up to 15% of the fine particle, and also within 15 minutes, less than 15 minutes, it eliminates 99% of the viruses, including COVID viruses, same like COVID viruses. Okay. If you just look at the structure of it, the first part would be having a electrostatic charge particle filtration system. Then next part is a mechanical filter, which is not the same one, but having a different layers. As I said it before, all it help in providing the healthy air, filtered air. The parts of it, if you can see it, are the controlled electrode, discharge controls, filter element, activated layer, then grounding electrode and DC-DC converter. As we know that electrostatic filtration works on the high voltage on the DC, so we have to have a DC-DC converter also. So let's see the benefits of it. The clean air filter, it immediately, as we know that within, let's say, 15 minutes, eliminate over 99%, or let's say deactivate 99% of the bacteria. It's much better than, like say, UV technologies, because UV technologies, total cost of ownership increases linearly over the time, because of the technology itself calls for the replacement of its parts, bulbs, etc., at a certain period of time. But here in the blue filters, nothing like that. At the same time, we have the same amount of healthier air, better air. There are various other, let's say, if I just start comparing UV technologies, there are various other uh, negative aspect of it. Uh, like you cannot have the full filtration or let's say full cleaning of the air within the same span of ducting system or like the HVAC system, because the air has to remain in the contact of the UV system for a certain period of time for killing the bacteria or the viruses or deactivating them. Uh, or if you wanted to, on the contrary, if you wanted to increase the, let's say, the intensity of it, it comes into, let's say, profile where it becomes harmful to the systems as well as by chance if it come in contact with humans. So there are so many disadvantages of UV technologies versus blue filter, which is safer, cleaner, and then gives the same performance. It's directly replacing the standard filter, so there is no point and there is no, let's say, uh, problem in implementing it, and cost-wise slightly higher than the standard filter, but it's a good solution. It's a, like say, uh, good bargain between the healthy environment inside versus the cost. So this is one of that. And if I just go on, as I said it, I would be talking about refrigerant. Another pillar which I talked about is the alternative refrigerant. Let's talk about first the world of the refrigerant. We have seen it that there is a Kigali amendment which happened on the Montreal Protocol. The Kigali Amendment to the Montreal Protocol is basically an international agreement to gradually reduce the consumption and production of hydrofluorocarbons. It's basically a legally binding agreement which happened across all the signing countries. As per the agreement, these countries are expected to reduce their carbon footprints, or let's say hydrofluorocarbons, specifically if I talk about 80 to 85% by 2045. And by this, we expect that 0.5% global warming temperature would be reducing, let's say, by 2100. Okay, there are basically three groups in it. India comes in third group. The first group is of the developed countries, where they have to reduce by 15% of the carbon footprint of the baseline from 2012 by 2016. The second group is developing countries like China and Brazil. We basically come in the third group. In the third group, what we have to do is by 2028, we have to reduce 15% of all the carbon footprint uh, by 2024, 26. This is all had to be done by 2047. So these are all the information available, which I'm just emphasizing here to the amenities. And if I just talk about what refrigerant we have it, since we started refrigerant in air conditioning, I've just point out my pointer. We earlier had CFCs, HCFCs. We checked on to HFCs. HFCs are nothing but R134A, 407C, etc. Then industry moved to HFOs, nothing but 134, the R1234YF, ZE, etc. Then to the natural refrigerant. Right now, the world is focusing on the natural refrigerant development world, like the first group, which I mentioned, developed countries. In India, we are still at HFCs. We are right now at 134A and 407C, specifically on the railway air conditioning systems. And we are hoping to go to HFOs or alternate like 513A. That's where we are. So if I just go further, if I just try to see that what Wabtec has done it so far, we are actually have seen CO2 systems already. We have not found them much suitable. We have found them, let's say, uh, uh, they cost us a lot, of course, and they are not there for all the climatic controls zones. Other than that is R290, which is a natural refrigerant, okay, which is propane basically. Uh, Compared to, let's say, HFCs, which are, let's say, having very high global warming potential, 1430, close to 1500 compared to CO2. And we have HFOs like 1234YF and ZE, the blends, they are giving around 4, but here R290 is at 3, which is very close to CO2 and very apt for environmental friendliness. So what it gives me, let's say, uh, how can I say about the effect of it on, let's say, performance? If you have a look at this picture, you can see that HFCs are very close to R290. Both are almost same. So we can really understand that its potential on, let's say, energy consumption as well as, let's say, cooling capacity or the effect on the refrigeration system is pretty same. Let's go to the next slide and see more on the weight of the refrigerant system and dimension. If we just see CO2 and air, basically they are pretty heavy, pretty big units because CO2 works on very high pressure as well as same like air. The application of the air can only be like for the aircraft industries where the turbo machines are there for cooling the aircraft. CO2 can be used only to the, let's say, cold environment regions much efficiently. But when it comes to the higher environment regions like India and all, it becomes really inefficient, and then system works on, let's say, higher envelopes, and then gives a lot of trouble. I'm speaking about mobile air conditioning system. There has been some systems developed for the industrial refrigeration and air conditioning on CO2 for India. They had some successes for proving it, but not on the mobile air conditioning. Uh, if I just talk about, let's say, one of a cost, CO2 and air-based solutions significantly are higher, as I said it before, but R290 doesn't go like that. The systems are pretty comparable to HFOs. The cost, the size, the unit is pretty same. There'll be it's not a one drop of solution. So if you're using HFOs or HFCs right now, you cannot simply go on to R290. You have to change something, but the retrofitment, yeah, there'll be some retrofitment, but it is possible to produce the refrigeration unit in the same domain, space domain as well as the cost domain. Let's talk about another aspect, flammability of R290. We know that flammability is not excluded from the refrigeration systems. We know already the hydrogen, uh, Just for example, I've just given it here. Hydrogen used in the fuel cell, hydrogen being highly flammable. Next is lithium ion batteries, which are also flammable in nature, but they are used widely. There are hydrocarbons also, we know that. So the point is here is that there are flammable substances, but when there are ways and methods to use them and incorporate them into the equipments in a safe way. R290, especially, we have developed the system. Uh, we have identified the risks in the life cycle for, let's say, in-service operations, standstill, maintenance, repair, as well as in case of the accident also, and forcible misuses. So we have identified all the risks. We have mitigated all the risk. We have done all the risk evaluation with TUV North, TUV South, and also we have done the evaluation of the risk with the Federal Institute of Material as well as Federal Railway authorities in Germany. They've all cleared it. And as a result, uh, we have developed one unit, and that unit is placed it on Deutsche Bahn, one of the train, which is running since July 2020. We are gathering the details and data on it. So far, is pretty good and proving. So, in nutshell, Webtech has a solution, R290, as a natural refrigerant, which is having a very low global warming potential, which is very good on environment, as well as not, let's say, uh, problematic from flammability point of view, operation point of view, and it's proven. So that's one part on R290. Another part is on energy saving. Uh, Here, let me give a little detail that HVAC, as we already know, that HVAC consumes approximately 20 to 40% of the energy next to traction, basically. So having seen this much of the energy consumption from the HVAC, it is required that we are equally uh, apt on energy saving as well. One part of the energy consumption that happens from this is to control the temperature and the heat ingress that comes the from the fresh air. We know that the fresh air is needed inside the saloon or the car, which has to be kept within a specified limit for the passenger's health and safety. Now, to keep it that much precise level, there are various controls on it. The current control is a load-based control. In that control, we basically operate the damper that you see it over here based on the load system. So if you have uh, more passengers, the damper opens up more fresh air is driven in, and the levels of the CO2 is maintained. On the contrary, when there are less people, the damper closes. This is the current control. What are the problem with the current control is that the steps in which this operates is pretty large. They are operating in 0, 25%, 50%, 75%, and 100%. And as well as when the train comes to the station, or let's say metro train comes to the station, that time a lot of fresh air comes in. There is no much change in, let's say, the passenger load, but still there are a lot of fresh air comes in. Despite that, this damper is kept in full open condition. It brings in a lot of air from outside, and then CO2 level basically decreases drastically, much lesser than the maximum specified limit. The specified limit is, approximately, let's say 2,500 to 2,600 parts per million, it reduces drastically. So in that case, what is needed here is a different control mechanism for this temper to get controlled. What we have done it is that we have set a CO2 sensor in HVAC. The app place for putting a CO2 sensor was the return air area, where the return air is actually the best representation of the CO2 level inside the saloon. Based on the reading from the CO2 level, we have designated algorithm which is customizable to every train, every car, as well as every operating condition and every climatic zone. That software controls opening and closing of the damper precisely. And response system of this is pretty high. So when we control the fresh air precisely to the accurate level of, let's say, uh, CO2 level inside the car, we basically save on the energy. We basically save on the heat which is coming in from outside as through the fresh air, and we gain the benefits out of it. We have seen it that approximately 10 to 30% saving can be there, which is depending on several conditions, basically the environment, the load, let's say the design of the car, the insulation system of the car, the train running time, hours, season. There are a lot of parameters in it, but on an average, 10 to 30% we can save. On one instance of our testing, we have seen it. If you can see this, at different condition, 44 degrees Celsius, 33% relative humidity, ambient condition, and when the car was set at 27 degrees Celsius, we have saved 15.6. And correspondingly, other values, 15 to 18%. That was a specific case that where we have implemented in India in one of the metro and then seen the benefit out of it. So this is basically the CO2 sensor, which is designed by us, and it can be placed inside the return air opening, as you can see it on the picture, and it is operated with the controller, 24-volt DC controller, which is very well available, not a problem. So with this, basically, we can achieve 10 to 20, 15, 30% saving, which is which can be customized based on the application. So that's pretty it. Three major topic. I just wanted to present it to you. Three technology endeavors that we had done it so far. The one that I presented in the last CO2 control system is pretty implementable in India right now. The other R290 refrigerant system is let's say so far being running in Europe, very well available for India, depending on the availability, its usefulness on various feasibility type and maintainability and all the aspect we can introduce it to the Indian market. The other one, blue filter, is also very well available. Uh, this is also, applicable to the Indian market. I hope I have, intricated little anxiety in all of the viewers. I'll be available for the question and answer in the live session. looking for you to take your questions and answer that. Thank you all. Thank you.
Yeah. Thank you so much. Let me switch off the